So, as you should remember, all information in binary, and therefore all information in all computers, is numbers. There's no other type of information. Well then, how do we store other stuff, like a book? Well, we have to use numbers to represent the other stuff. Kind of like some simple secret codes that you might have created as a kid. So why don't we make one of those right now? For simplicity, we'll just use the letters of the English alphabet, A through Z. So we're going to assign a number to each letter, and for reasons you'll see in a few minutes, we're going to start the letter A at 97. The numbers go in order with the letters, as you can see. And this puts Z at 122. So if we use our letter code to spell the word book, then we get 98, 111, 111, 107. How about another one? Let's do blue car. The word blue comes out as 98, 108, 117, 101. And the word car is 99, 97, 114. But what do we do about the space? We only have letters at the moment, so we'll need to add some more things. A space is not a letter, though, of course. So instead of thinking in terms of letters, we can use the concept of characters. Each thing, whether it's a letter, a number, a space, or something else, is now called a character. Okay, so with this character structure, we can include punctuation, spaces, symbols, and more. And the number for a space is going to be 32. So now we have 98, 108, 117, 101, 32, 99, 97, 114. This is blue car with the space in it. Note that we only have lowercase letters in our set. To add capital letters, we're going to have to repeat all of the same letters, but this time they'll be in uppercase. And capital A is at 65, which then puts capital Z at 90. All of our character codes are less than 255, and that means we can store them with just 1 byte. But if we're going to use a byte, then that means we can actually fit a lot more in there too. There is a standard version of character codes that use just 1 byte, and it started in 1960, and it's been the same since a modification in the mid-80s. And it's called ASCII, ASCII. And this stands for the American Standard Code for Information Interchange. It actually comes from telegraph codes. So telegraphs had the same problems as computers, after all, which is, how do you handle all kinds of useful information, such as words, if all you can do is go beep beep, pause, beep beep, beep beep. And so the ASCII character code set only has, though, 128 items in it. That's because it was originally built with 7 bits and not 8. Remember, it does come from long ago. And so you can easily find a chart with a full set of ASCII characters just by searching ASCII chart on the web. So they're everywhere. So when you're typing on your keyboard, what do you think is happening? Well, on the most basic level, your keyboard is sending numbers in the form of binary, of course, electrical impulses of on and off, right? Sending that to the computer. Then it's all of the software that turns that into text and displays it on the screen. So you can type ASCII codes directly into the computer and display them directly if you have the right setup. Probably a PC, and then if you're, so a Windows computer. And so if your keyboard has a number pad, then you can try holding down the Alt key while you type in a number on the number pad. And then when you let go of the Alt key, it should type the character for that code on the screen. You might have to put number lock on, by the way, numlock, right? So you can test it. Try it, hold down Alt, type 65, so 65, and release Alt, and see if that types a capital letter A into, whatever you're using, Word or, wherever you're typing, or an email or something. So, but if you're on a laptop, this probably won't work, by the way. There's some tricks, but you'll have to figure out if yours can or can't do this. And if you're on a Mac, then you can just have fun anyway. Hold down the Option key and hit any other key and see what that types actually. So some fun there. But okay, so anyway, so back to the character set. In addition to characters you can see, the ASCII code set also contains characters that tell the computer to do something instead of show something. Character number 10, for example, goes to the next line. And this is called a new line these days, and it used to be called a line feed, back when these codes were used to control printers directly. That's because it would make the printer roll the paper a little, and therefore you'd get a new line. So, character number 7 tells the computer to make a sound. It's usually called bell or beep if you look at ASCII charts. Not all computers still respond to this code. So if yours does, and you have a number keypad and you can type it in directly, please enjoy this code responsibly. It can get seriously quite annoying to have someone in the room who knows how to do that. So these types of characters are called control characters or control codes, the stuff that you don't see but it tells the computer to do something. With only 128 characters in the ASCII set, though, we quickly ran into problems when computers became popular. There are so many languages in the world, and so many different symbols and letters and special characters, that if computers were going to exchange information in any language aside from English, we would have to get a much larger character set than the original ASCII set. So this set is called Unicode, and it has over 100,000 characters. It was started by Xerox and Apple in the late 80s, and it's grown since then. And so now Unicode covers everything as its name implies, right? Like Unicode, one code, right? So, but it doesn't work exactly the same as ASCII does. The first 128 characters or codes in Unicode exactly match the ASCII codes. And this is really good because it made it easy to convert over because it was an exact match, right? Made it easy to move to the new system. But Unicode doesn't match a number with a visual symbol. It actually avoids defining how the character will look. It just matches a number with the name of a character, or you could think of it as the concept or the definition of a character, and then it lets each computer and piece of software decide how to draw it. Fortunately, it all turns out pretty much standardized, not a lot of differences between systems, so it comes out to pretty much the same thing where a number means this symbol. The numbers in Unicode there, character numbers, are called code points, just if you want to be official about it. And you can find Unicode charts for every different language, usually just by searching on the web. If you want the character set for, let's say, German characters, then you could just type in a web search for like German Unicode chart, right? And you should be able to then see any special characters that apply for when you're using that language set. So there's one more thing that you need to understand about Unicode, though, and that is that the number of bytes used to represent the numbers or used to represent the characters can be flexible. The most popular way to store Unicode information, which also includes ASCII, so what we're talking about now is just think all text, right? The most popular way is a format called UTF-8. So this doesn't mean that we use 8 bits to store 100,000 characters. That's just not possible. You can store 255 characters with 8 bits. UTF-8 uses 1 byte when it can, and more bytes, up to 4, as needed. That's flexible. It's a common misunderstanding that UTF-8 means ASCII, or the 8 bits, right, of the original, and that UTF-16 means Unicode. That's not the case at all. UTF-8 encompasses all of Unicode, and it just might take any number of bytes, 1 through 4, to do it. So, and you will almost certainly be dealing with UTF-8 in regular circumstances. You'll rarely ever need anything else. Handles it all. It's actually, UTF-8 is the primary encoding format used on the web. So if you do any web development or web design where you may do some layout, you might notice that actually you see things like char set equals, then in quotes, UTF-8. That's what that is. That's why that's there. And if you go changing it, you're actually going to deviate from the simplest way to get universal language information into your web page. So maybe take note of that. So it's the primary encoding format of the web, and it's becoming the standard all over the place, actually. Smartphones included, that's UTF-8 is the way to go, or the primary thing there, the most common. So we looked at how number information can be used to store text. We learned about the standard system, a standard system for doing it called ASCII. Then we looked at the bigger picture and learned how actually Unicode brings all the languages of the world into one character code set. And this structure is behind everything you can read on a computer. So now you know actually how it works and where it came from.